In this video, I'm going to talk about prime and composite numbers and prime factorization. First, let's talk about what factors are. A factor is an integer that can be multiplied by another integer to give a specific number. So, for example, the number 15, you can multiply 3 times 5 to give you 15, and you can multiply 1 times 15 to give you 15. Those are the only positive factors of 15, the only numbers that can be multiplied to give 15. So 1, 3, 5, and 15 are the factors of 15. Here you might have noticed that 10 and 30 both have several pairs of factors in their lists. On the other hand, 7 and 19 just have one pair of factors each, 1 times 7 and 1 times 19. There are no other factors for those numbers. Numbers like that with just one pair of factors, 1 and itself, are called prime numbers. 19 is prime and 7 is prime because each of them can only be divided by 1 and itself. On the other hand, 10 and 30 have several factors in addition to 1 and themselves. 10 has factors 1, 2, 5, and 10, and 30 has factors 1, 2, 3, 5, 6, 10, 15, and 30. Numbers like that, with multiple factors beyond 1 in itself, are called composite. This distinction between prime and composite numbers is a really important one to understand for this concept. It's also worth noting that every natural number is either prime or composite, with the exception of 1. 1 is neither prime nor composite. It's just 1. But every other natural number is either prime or composite. Now that we've got a handle on factors and prime numbers, I'm going to give a little example that might seem kind of off the point, but I promise it does have a purpose. So maybe you have experience with cooking or baking and following a recipe, a list of ingredients that tells you what you need to put together, mix up, put in the oven, and make something. So, for example, if I was going to make cookies, I might need eggs, butter, sugar, flour, whatever the recipe tells me. Put that all together, bake it, great, end up with cookies. That means anytime I follow that recipe in the same way, I can expect to get cookies again. I would not expect to follow a cookie recipe and get cookies one day and hamburgers the next day. That would be impossible. Numbers, in a certain sense, also have recipes. Of course, these recipes don't call for eggs and butter, but the ingredients in a number recipe are prime numbers. So for example, if I picked some prime numbers that I liked, say 2, 3, and 5, and multiplied them together, that would give me 30. That means that 2, 3, and 5 are the recipe for 30 in a certain sense. If I pick other numbers, different prime numbers, and multiply those together, I would not get 30. 2 times 3 times 5 is the one and only unique recipe to give me 30. In the same sense, if I use 2, 3, and 5 again another time, I would expect to get 30 again. That recipe will always give me 30 and is the only way to give me 30. If I tweak the recipe a little bit, say if I change it to 2 times 3 times 5, that's a different recipe and I'll get a different number. In this case, I'll get 60. The real mathematical term for that recipe is called prime factorization. Suppose I have a specific number in mind and I want to know what's the recipe or prime factorization for that number. Take 180 as an example. If I want to know what prime numbers go into making 180, I can find out by starting to divide 180 by any of its factors. They don't have to be prime factors. So for example, I could start with 10 and 18, since 10 times 18 equals 180. Then I just continue that process. So the factor of 10 has its own factors of 2 and 5, the factor of 18 has its own factors of 3 and 6, and then 6 can be further divided down into 2 and 3. Notice that when I get to a prime factor, I have to stop. It's a dead end. It has no more factors beyond itself and 1, so that's where we stop. So after 180 has been divided down to its prime components, we can see what are those prime factors, or the ingredients of the recipe. Here we have 2, 5, 3, 2, and 3. If we put those in order from least to greatest, it's 2, 2, 3, 3, and 5. Since this is multiplication, we can consolidate the repetition with exponents. 2 squared times 3 squared times 5. So the recipe, or prime factorization, of 180 is 2 squared times 3 squared times 5. And we can check that by actually going ahead and multiplying 2 times 2 times 3 times 3 times 5, and seeing that it does indeed equal 180. so we did this correctly. Suppose someone else had a different approach for finding the prime factorization of 180. Suppose instead of starting with 10 and 18, they started with 2 and 90. This is fine, 2 times 90 is 180, but is this different approach going to lead to a different result? Let's see. As you can see, this approach led to the exact same result, 2 squared times 3 squared times 5. The takeaway here is that it doesn't matter what composite factors you break your number down into in what order, you're always going to end up with the same prime building blocks. Now let's look at 2 more examples of finding the prime factorization for a composite number. Before we close, I want to put a question out there for you to think about. Now you've seen how to find the prime factorization of a number. How can you use that prime factorization to compare numbers and see how they're similar and how they're different? Keep an eye out for my next video if you're curious to find out. I hope you enjoyed this video, and thank you for watching.